Okay. Determining the mass of the Earth. We know that the force due to gravity, Fg, is equal to m1g, where g is the acceleration due to gravity, and using Newton's universal law of gravitation, capital G m1 me over r sub e squared. Me is the mass of the Earth, r sub e is the radius of the Earth to the surface, where m1 is stationary at this time. So we divide out m1, and we have g is equal to capital G m sub e divided by r sub e squared. Now this can be used to find the gravitational field at any distance r. Okay, so let's rearrange this. We're solving for me multiplied by r sub e squared divided by capital G. Excuse me. So that me is equal to r sub e squared g divided by capital G. Now, Cavendish, in a great historic experiment, determined that the universal gravitational constant G is 6.67 e negative 11 Newton meter squared over kilogram squared. And when we substitute G and r sub e, we find that the mass of the Earth is 5.98 e to the 24 kilograms, and you find this information on page 185. Now, this is what I want you to know. You should be able to state Kepler's 3 laws, including any equation that's attached to those. Newton's law of gravity, page 182, and third paragraph is where the law is actually stated, and then be able to write the equation for the universal law of gravitation, which I just gave you. Fg is capital G m1 m2 over r squared, where r is the distance between the centers of m1 and m2. Now let's continue. Consider masses that orbit other large masses. Now we have to assume that m is much, much greater than m1, because m is the gravitating mass, the large mass, and m1 is orbiting around m. So the center of mass distance from m to m1 is r. So we could then say that this distance from tangent to the center, this is the altitude or the height that we're orbiting above that planet. Now we know that the force centripetal is equal to m1 ac, which is acceleration centripetal. We also know that Fg is equal to Newton's law of gravitation. And so we want to find m1 is going to orbit m such that the gravitational force is providing the centripetal force. So we're going to say equate these two and solve for AC. So the gravitational force is causing a centripetal acceleration so that it's gm over r squared, where m is the large gravitational mass. And the reason I point this out, because if you're orbiting the sun, then this is the mass of the sun. If we have a satellite or the moon orbiting the Earth, then this is the Earth's mass. So whatever the gravitating mass is, the large mass that's providing the centripetal force, that's what the m is. So we find then that the centripetal acceleration is vt squared over r, and this is the transverse velocity. It's the linear velocity as we go around in our orbit. So now if we say that v sub t squared over r is equal to gm r squared, because those things are equal to each other, we now rearrange and solve for v sub t squared. So we get v sub t squared is mg over r, or the velocity, linear velocity of the orbit, called the orbital velocity, is the square root of gm over r. Now, since the small mass m1 is orbiting, then we make one complete revolution of orbit where the circumference, that distance, is 2 pi r. So the period of revolution, how fast does it take to go one time around, is the circumference divided by the velocity. Now this allows us now to find this period, and it's simply the circumference 2 pi r over v sub t, which is 2 pi r over the square root of gm over r. Now that's the square root of this whole thing here. And we're going to square both sides. So t squared, this becomes 4 pi squared r squared. Now square root, I square the square root, I get gm over r, which this r comes in the numerator, so I get t squared is 4 pi squared r cubed over gm. Wow, Kepler's third law. And so t is equal to 2 pi square root of r cubed over gm. Two things to consider here. R is the orbital radius from center to center, and m is the larger gravitating mass we just talked about. This is page 187. And now what I want you to do, be sure you understand and read example problem 2 on page 188. Your assignment, we're going to call it HW 7.2 colon 14 through 17. It will be graded and is at the beginning of your next class. Have a good day.